Radhe Radhe students. Today we will continue this chapter measurement and experimentation. We have already completed some part of this chapter in previous lectures. So this chapter is very important and you will get 3 to 4 questions in your board exam as well as in competitive exams like Science Olympiad. So let's start with physical quantity in this lecture. Physical quantities are those quantities which we can measure around us. And in this lecture, we will also learn how we measure this quantity with the help of various instruments. So physical quantity is divided in 3 types. First one is fundamental physical quantity, second derived quantity and supplementary quantity. Fundamental physical quantities are those quantities which are independent from each other. That means you cannot relate one quantity with other quantity. So you cannot convert mass into length and time, or by multiplying any other quantity, you will not get mass or length or time. So these quantities are independent from each other. So they are named as fundamental physical quantity. Derived quantities are those quantities which can derived by multiplying or adding or dividing fundamental quantities. For example, velocity. You can find velocity of any object by dividing displacement with time taken by that object to cover that displacement. Okay. Similarly, you will get force by multiplying mass and acceleration. So derived quantities can be expressed in terms of fundamental physical quantities. Apart from these quantities, two type of quantities, some supplementary quantities are also there, which is plane angle and solid angle. So we use radian for plane angle and steradian unit for solid angle. So we will learn about this term in higher classes. So for our syllabus, we will continue with these quantities. So SI unit of mass is kg, SI unit of length is meter, time second, temperature Kelvin, electric current ampere, luminous intensity candela, and amount of substance mole. And you can get unit of these quantities by multiplying or dividing fundamental quantities. Okay, so let's move to next slide. In second part, we will learn how to convert from one unit to another unit by using some prefix. So here I have written some prefixes. Micro is used for 10 to the power minus 6 in metric system. For 10 to the power minus 3, we use milli. For centi, 10 to the power minus 2, kilo, 10 to the power 3, mega, 10 to the power 6, and nano, 10 to the power minus 9. So if you want to convert 1 centimeter to meter, then you have to replace this C, centi, with 10 to the power minus 2, because 10 to the power minus 2, in place of 10 to the power minus 2, we use centi. So this is equal to 10 to the power minus 2 meter. If you want to remove this centimeter square to meter square, then you have to multiply here by 10 to the power minus 4. So you have to multiply by 10 to the power minus 4, and 1 centimeter cube. Similarly, you can convert this 1 centimeter cube to meter cube by just multiplying by 10 to the power minus 6. And in place of milli, we can use number milli 10 to the power minus 3. So it is millimeter square. So we'll write here 10 to the power minus 6. Okay. So let's move to next slide, third, second. Yes, second slide. So after this, we will learn about some instrument. So in this chapter, we will learn how to take reading from various instruments like a meter scale, and this is a screw gauge, and another instrument I have vernier caliper. One by one, we will learn about all these instruments and how we take measurement from this instrument. Okay, so let's start with this meter scale. As you can see here, I have this meter scale, and you can see here clearly on each millimeter a division is made on this scale. Okay, on each millimeter. This is for inch, and this lower division is for centimeter. So 1, 2, 3 like this centimeter. On each centimeter some number is written here. Okay, 4 centimeter, 5 centimeter, 6 centimeter. So if you try to take reading from this scale, then you have to see this left end and right end. So left end of this ball is at 1 centimeter. You can see here, this is 1 centimeter mark. Yes, 1 centimeter mark, right? And its right end is at 7.7. 7, this is 7, and 1, 2, 3, 4, 5, and this is 7th mark. So 7.7 meter. So we can say that diameter of this ball is 7.7 minus 1, which is 6.7 centimeter. So for this scale, we can write least count of scale is 0.1 centimeter, 0.1 centimeter, or 1 millimeter. Okay. So now we will start learning another kind of instrument which is known as vernier caliper. So as you can see here, this is vernier caliper, and we can measure diameter of any object by using these two jaws. This is used for measuring outer diameter, and this is used for measuring inner diameter. So how we can measure inner diameter of any cylindrical object? Let's see. You have to use these two jaws to measure inner diameter. So this slider, you can slide it, you can see here. And to measure inner diameter, we use these two jaws, and you have to fix it inside it. Now you can take reading from this instrument. And to measure its outer diameter, we have to use these two jaws like this. You can take reading from this. Now we will see how we can take a reading from this instrument. Student, this part is used to take depth of a cylinder or any object. So as you can see here that there are two kind of scale in vernier scale. One is linear scale. This one is linear scale or main scale, and this one is vernier scale, or you can also slide it over this linear scale. So for 10 division in this vernier scale, as you can see here that there are 10 division on this vernier scale. So 10 division of vernier scale is matched with 9 division on main scale or linear scale. So we can write here 10 vernier scale division equal to 9 main scale division. So one main scale division is 0.1 centimeter, right? This is normal scale which we use in geometry box. So one, and this is 1. So one division on this main scale, is equal to 0.1 centimeter. So 10 vernier scale division is 9 main scale division. So 1 vernier scale division equal to 9 by 10 main scale division, which is equal to 0.9 main scale division, right? So minimum length measurable by this instrument is 1 main scale division minus 1 vernier scale division. Okay, and 1 main scale division is 0.1 centimeter minus 1 vernier scale division is 0.9 main scale division, 0.9, and main scale division, in place of main scale division you can write 0.1 centimeter. So if you subtract this value, you will get 0.1 minus 0.09, which is going to be equal to 0.01 centimeter. So you can see here clearly that least count of this instrument is 0.01 centimeter. Okay, student. So least count of vernier caliper is 0.01 centimeter, right? So now we will learn how to take reading from this instrument. Yes. Suppose you want to measure length of this pencil, then you have to fix this pencil between these two jaws. And for this, you have to slide this slider over linear scale, right? And suppose your vernier scale, which is movable, this is vernier scale, which you can see here, it's moving over linear one. So if your vernier scale comes at this position, then you can see here this this reading. This is 2.1, 2, 3, 4, 5, 6, 7, 2.7. So our main scale reading equal to 2.7 centimeter, because on linear scale it is calibrated at each millimeter or each 0.1 centimeter. So main scale reading is 2.7 centimeter. And what is vernier scale reading? So for vernier scale reading, you have to find that division on vernier scale which is exactly matching with main scale division. So here, fifth, this one is sixth. Sixth vernier scale division is coinciding with main scale division. So vernier scale reading is 6. So sixth vernier scale division is matching with main scale division. So you have to take reading of vernier scale division equal to 6 into least count of this instrument. So we have already determined least count of this instrument as 0.01 centimeter. So vernier scale reading is 6 into 0.01 means 0.06 centimeter. So what will be the total reading of this instrument? Main scale reading 2.7 and vernier scale reading 0.06. So total reading is 2.7 main scale reading plus 0.06 vernier scale reading. So total reading is addition of these two terms 2.76 centimeter. Is it clear? Let's move to next slide. Learn about zero error in vernier caliper. Zero error in vernier caliper means if you bring these two jaws together and zeroth division on vernier scale is not exactly in front of zeroth division of linear scale or main scale, then we say that there is some zero error in this instrument. So how to change our final answer taken by this instrument having zero error? So you have to subtract positive error from your final reading and add negative error in final reading to get true value. So as you can see here that zeroth of main scale is not matching with zeroth of vernier scale, but third division is matching. So error in this instrument, positive error in this instrument is 3 into least count, which is 0.01 centimeter. So 0.03 centimeter is positive error in this instrument. Okay. So in final reading, you have to subtract this value 0.03 to get true value. Is it clear? Yes. Let's move to negative error. So this instrument has negative error because here also zeroth of vernier scale is not matching with zeroth of main scale. Here zeroth of vernier scale is towards left of zeroth of main scale. So in this instrument there is some negative error. So how to change our final answer to get true value? For this you have to see which division is matching with linear one. So here one, this is zeroth division, this is first division, this is second. Second division on vernier scale is matching with main scale division. So here error is 2 vernier scale division minus 1 main scale division. This is error. Let me select a color pen. This portion is negative error in this instrument, which is equal to 2 vernier scale division minus 1 main scale division. So 2 vernier scale division minus 1 main scale division. 2 vernier scale, we will start learning another kind of instrument which is called screw gauge. So you can see here in my hand, this is screw gauge. You can take reading in millimeter by using this instrument. So you have to just rotate this circular scale over linear scale and it will advance in forward direction and you can measure thickness of any object. So before calculating thickness of this object, we will try to find least count of this instrument. So there are total 100 division made on this circular scale. So you can see here total 100 division, and if you rotate it, it will move in leftward direction. And for one complete rotation of circular scale, it will advance through 1 millimeter, right? One division on linear scale. And one division on linear scale, one linear scale division is equal to 0.1 centimeter. So for 100 circular scale division, 100 circular scale division, 0.1 centimeter length, this circular scale will move over linear scale. So for one circular scale division, 0.1 by 100 centimeter, which is equal to 0.001 centimeter. So if you rotate just by one division on circular scale, then it will advance on linear scale by 0.001 centimeter. So minimum thickness measurable by this instrument is 0.001 centimeter, right? So let's try to find reading of this ball. So this ball is fixed between these two ends, and here you can see that 10, 11, 12. 12 main scale reading is there, or linear scale reading. So linear scale reading is 12 into 0.1, and 1.2 centimeter. 12 division on linear scale, and each division on linear scale is equal to 0.1 centimeter. So 12 linear scale division equal to 12 into 0.1 centimeter, which is equal to 1.2 centimeter. So this is linear scale reading. 1.2 centimeter is linear scale reading. Okay. Division is matching with reference line. This is reference line. This line is line on linear scale is reference line. So suppose second division of circular scale matched with reference line. So number of division matching with reference line is 2. Then we will write here circular scale reading equal to 2 into least count. Least count is 0.001 centimeter. So total reading will be equal to linear scale reading plus circular scale reading. Total reading equal to linear scale reading plus circular scale reading. So linear scale reading is 1.2, circular scale reading 0.002. So total reading is 1.202 centimeter, right? Now we will learn about zero error. So there are two type of zero error: positive zero error and negative zero error. So if you bring these two end together and zero of circular scale is not in front of reference line, then you can say that this instrument has some zero error, is not matching with reference line. Here you can also see that zero of circular scale, this is zero of circular scale, and it is not matching with reference line. So this instrument has some error. So how to find this positive error? So you have to count which division is matching with reference level. first, second, third. Here third division on circular scale is exactly in front of reference line. So positive error in this instrument is 3 into least count 0.001, which is 0.003 centimeter. So positive error in this instrument is 0.003 centimeter. So this error should be subtracted from final reading. Suppose you are getting final reading as 4.004 centimeter, right? Then your real reading or exact value is equal to this minus this positive error, means 0.003. So your final reading will be 0.001 centimeter. So positive error is to be subtracted from your final answer measured by this instrument, and negative error is added in your reading taken by this instrument. So this instrument has negative error, and how to count this negative error? You have to calculate which division is matching here. Suppose sixth division is 96th division is matching. So for finding negative error, you have to subtract it from 100. So 100 minus 96, which is equal to 4. So 4 into least count 0.001, that means 0.004 centimeter. So you have to add this value, this negative error, in your final answer to get true value. Okay, with positive and negative error and how to take reading from this instrument. Okay, so that's all, and how this simple pendulum is used to find value of G, which is 9.8. And we will also find time period of simple pendulum and its relation with length of the pendulum. Okay, and for this purpose we will use this stopwatch, which we use to measure time taken by this simple pendulum to complete 10 or 5 oscillations. So we will take reading for 5 oscillations. So how to take reading? You have to bring it on extreme position and drop it and count 5 oscillations. 1 oscillation, 2, 3, 4, 5. So for this time, you have to take this stopwatch and measure time taken in this 5 oscillation. For here, I am considering that time taken is 10 seconds and number of oscillation is 5. So for 5 oscillations, number total time taken is 10. So for one oscillation, it will take 10 by 5 seconds, which is equal to 2 seconds. So we can say that time period of this pendulum is 2 seconds. And here length taken is, suppose this length is 25 centimeter. Length 25 centimeter. So if you take a longer length, if you take another length, which is suppose 40 centimeter, then for 40 centimeter, you will get a different time period of oscillation. How to take time period? I am again explaining. You have to bring it at extreme position and make it oscillate. 1 oscillation completed, 2, 3, 4, 5. And you have to measure time taken for this 5 oscillation. So suppose time taken for this 5 oscillation is 20 seconds. 20 seconds. So here for 5 oscillation, time taken 20 for, so for each oscillation, time taken will be equal to 20 by 5, which is 4 seconds. So you can see clearly, as we increasing length of this thread, time period is also increasing. So we can say that time period is directly proportional to length of pendulum bob. Okay. So to calculate value of G using this formula, T equal to 2 pi root L by G, we will take different reading with different length and time period. So we'll draw here a tabulation in which on one column I will write time period and on other column I will write this one, length, right? So for different time period, for length 40 centimeters, suppose time period is coming 4, for 20 it's coming 2. So like this you have to take different observations. And finally, you have to take average value of L and average value of T and also average value of T square. And you have to put here average value of T square and L. And this is pi is constant. You can take its value 3.14. So if you calculate this value, you will get G equal to 9.8. Okay. So now we will try to solve one numerical based on this simple pendulum. Yes. Suppose at a place where G equal to 9.8 meter per second square, the period of oscillation of simple pendulum is 1.9 second. Time period is given 1.9 second. You have to find length of this pendulum. So if you use this formula T equal to 2 pi root L by G, then you will find that only one variable is there. T is given, time period is 1.9, 2 is a number, pi is 3.14. You have to calculate this length and value of G is 9.8. So by simplifying it, you will get value of L equal to 0.9 meter. Okay. So that's all in this lecture, student. Try to practice some more questions from your textbook and revise these concepts. Okay. Radhe Radhe.